The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally gotten.
Hello, everyone. My name is Dane Dupont. I'm joined today by Mr. Luatori. Phil is with us, but not with us. He's going to be able to do the update, which was recorded a couple hours ago. We'll play the video for you. But then Lou and I will be taking over the rest. And as a little bonus today, we have a discussion about the Kamchatka magnitude 8.8, but more specifically, about the fake AI generated videos that we saw while the event was occurring. So we'll talk about that at the end. How you doing today, Lou?
I'm doing pretty good. How you doing?
All right. Busy week as always, waiting to see what the volcano does. And
You didn't mention our Pohiki update as well today.
Yeah, we'll have a little bit on that as well. So have a busy agenda. So let's go ahead and get into it. What do you say?
Hit it.
All right.
Oh, here we go. There it is.
Well, everyone, this is our Hawaiian Volcano Summary for August 14th, 2025. In a week since Kīlauea's 30th episode of its ongoing summit eruption, the volcano has been recharging with magma and building pressure underground once again. We can detect this through monitoring instruments that show gas pistoning cycles out of sight underground in the vent area, whereas on the surface, all we are seeing in the last week is a settling of the ground surface following the release of gas from the recent lava flows. This is a B1 camera looking at the eastern side of the crater. And what you can see here is this sagging, downdropping of the surface of the crater floor where lava had covered it last week. Episode 30 covered about 80% of the inner crater floor here. And with very gas-rich flows, since the fountains were not very high, gas got mixed into the lava and distributed across the crater floor. And over the last week, we've seen the sagging motion across much of those lava flows. So the B1 camera here on the eastern side is picking this up quite clearly on the eastern margin. And if we come across the crater, we see this is evident across the whole southern boundary. To see the near vent areas, we switch to the K1 camera. Sorry, the KW camera. Here it is, with the vents shown in the east. And if I zoom into this, you can see here in the center some of these areas that pooled larger areas of lava are more visibly sagging as well. So that's all we can see on the surface. If we look at the thermal cameras for the last week, sped up since the end of episode 30, we see very few changes as far as heat distribution on a crater floor. We do see there's still heat coming from the vent that is not always visible through the volcanic emissions there. Visibly, we have seen the diminishing of glow following episode 30 and lava on the flow field. Mostly it's been dark for the whole week from the whole entire vent area, as you see this black screen here. The USGS does report that glow became visible from the south vent in the last couple nights, but very weakly and intermittently. So it's coming, but it's blocked perhaps shallowly in the north vent and other areas, and nothing really visible long term. Here is the ground tilt at the summit in blue, showing the resumption of inflation following episode 30. You can see we've not quite reached the same levels as we had prior to the onset of the most recent episode. But as you can see, those inflation rates start off more quickly and then sometimes will flatten out or even will go downwards, meaning that the onset of the next episode is more difficult to predict. So here you see that current pattern. You can see episode 30 also had that extra inflationary pulse just prior to the onset, which corresponded to the emplacement of the new dike, the new fissure that opened up on the west side of the crater, southwest side of the crater. And so any complications like that could also delay the onset. Here is the last 3 months. So you can see the greater pattern of how we've sawtooth this recovery. And then whenever an eruption episode occurs, we relieve pressure and drop back down our ground tilt before resuming over and over again. So we're still within that pattern. The USGS update from today notes that fountains are likely to start between August 16th and 20th. with only a little bit of glow overnight. Now there is a little bit of extra information here in the analysis that because there have, let's see here, because of the increase in elevation of the vent, magma is building more pressure beneath the vent areas and can be injected into weak areas. And that is likely what occurred during the fissure emplacement last week. So they say this is possible. This could result in permanent changes in event locations and of behavior. But currently, there are no indications that anything would occur outside of the summit region. The rift zone continues to contract, indicating no magma in that part of the system. So that is the prognosis for the next episode. We're building up, expecting perhaps a little bit more variability. The impacts still remain the volcanic gases and small bits of tephra that can blow with the wind. Here is the Purple Air Citizen Science Monitoring Network, showing low levels of gas across the island in between our episodes. Occasionally you see slightly higher values in the near vent areas. Even with our pause between episodes, we are putting out a decent amount of gas from the volcanic summit. And sometimes this wraps around to the Kona coast, and so you sometimes see these elevated values on the Kona side as well, as you see right here. But the main hazard is the big pulse of gas that comes out with the onset of each new episode. And when that happens, all of our island residents, especially in this southwest area and wrapping to Kona, should be prepared for the same patterns we've seen 30 times already within the last 8 months. The USGS has updated their table of eruption information, revising downwards the maximum fountain heights to about 50 meters or 200 feet or so, with a volume of 8 million cubic meters erupted during an episode, the third largest output thus far. And that's despite having very short fountains. Here is our under 200 foot fountains for episode 30. And you can see that, like 29, they were shorter than what we'd seen in the previous interval of 6 or 7 episodes. The volumes, though, if I put the volume up here for episode 30, you'll see that this is actually the third highest value, only excluding the first couple of events early on in the sequence. And so even though our fountains are not very high, we've put out a increasingly large amount of lava over the last few episodes here. And if we look at the discharge rates, which is how much lava is coming out over the length of that time, right? So the eruptions have different lengths, and so you can see how much is coming out per second or per minute. You can see that episode 30 plots quite highly here, a very high discharge rate, similar to many of the most recent episodes, and also similar to the very first fissure that opened this eruption back in December 23rd, 2024. So putting it all together here, if we look at the height of the fountains versus the discharge rate, what we can see is that episode 30 was most like episode 1, our very initial onset, which reinforces this idea that the summit is building extra pressure before it can burst out in a similar way as the eruption onset at the beginning. So those are our summary of the discharge rates and heights for this most recent episode 30. Moving forward, once again, here is our earthquakes for Kīlauea for the last week. We see a flurry of events here in the south flank, just south of the summit, as well as continuing small level events around the summit itself. So in this zoomed in view, this also corroborates this building pressure to summit that likely is increasing pressure on a flank and as well against Mauna Loa to the northwest. Deep earthquakes from Pahala continue. This is all associated with the hotspot feeder source of the volcano. We can presume magma is still coming in at a healthy rate into the volcano to cause all these changes at the surface. But overall, big picture, our earthquake rates per week are still quite low, as they have been ever since the onset of eruption in December. Once the pathways are opened, you normally have a less pressure building, and so this is why this change is so interesting here recently, that the pressure is building once again. And perhaps we'll see earthquake rates rise in the next weeks or months here. Looking at the ground position itself, this is the length of the summit caldera north and south. And you can see here is that we are stretching apart in our inter-episode periods. And when we have an eruptive episode, we seem to contract our accordion back. And this is a range of about 9 or 10 centimeters, or a few inches here that we're moving every week or two, stretching apart. As we mentioned earlier, that's contained to the summit area. This is a similar plot for the East Rift Zone by Pu'o'o. And what you see is a decrease in the values indicating contraction of the rift zone, and thus no new magma coming into it. So all is well down on the lower East Rift. We're watching for changes at the summit. Seems to be almost a reset of the summit eruption, where we're building pressure once again and could potentially reestablish vents or establish new vents in areas that we haven't seen thus far. And that's our Hawaiian volcano summary for this week. So mahalo for allowing me to expand a little more on that. I'll try to give you guys a little bit more insight here with some other information. So let's move to our volcanic hazards as usual. And to start off here, I'll play you guys the S2 camera daytime views over the last week. And primarily while we have trade winds blowing our volcanic emissions to the southwest, you can see several instances of time, including this very last capture here from a few hours ago today on Thursday. That shows the winds are variable and can blow to the south towards this camera and potentially other areas of the national park. So play this once again. You can see it for the most part, it's going to the southwest. Sometime around Sunday, you can see it flips towards the camera here. This is to the south. The camera's looking from the south. So, and then once again here today. So that's our main concern, is which direction the winds are blowing when this episode may occur. We don't know when it's going to occur exactly. So we're just kind of watching the weather patterns continuously here, especially as we get closer and closer to the expected onset. So that is our visible evidence of the gas. We typically go to our VMAP forecast from the VOG Measurement Prediction Project from the University of Hawaii at Manoa. Presently, it seems like the whole hawaii.edu website is down across the entire University of Hawaii system. So we will skip that today and move on to our Purple Air Citizen Science Monitoring Network. And let me check that this is updated here. And there you go. There was those elevated values here on the Kona coast. Right now we're showing 0 on Pahala, but if I were to click on that value there, we can try to pull up the history. And what you can see is that we're currently in the green, depending on the coming and going of the wind. That plume can blow across, and you can see within the last few days here, we've peaked into the yellow several times, even with this background emission rate in between episodes on Kīlauea. So we worry more about the gas coming out during the big pulses, but as we don't want to forget our residents that are living with this chronic issue of gas blowing down there, even between these big episodes over the last 8 months especially, and really going back further beyond that to when we had the resumption in 2020, and beyond that for the 10 years from 2008 to 18. This is not a new problem, but it is an ongoing, persistent problem for especially these communities southwest of Kīlauea and wrapping up the Kona coast as well. What we can show you is that on a global scale, we do have an accumulation of SO2 in the atmosphere here. So here's our main Hawaiian islands. You can see this largest concentration right over the big island here. But the accumulation of 30 episodes of gas is probably not all 30 here, but the more recent ones have been building this concentration of SO2 in the atmosphere over the Pacific for some time. So largely, this is what you see here. This has been swirling for months and months and months, drifts this way and that way. Pardon me. We also see in this image the remains of the eruption from Kamchatka, the volcano in Kamchatka, following the earthquake that occurred there a couple weeks ago. That generated the tsunami that we all have stories about if you live in Hawaii. So that's the big picture. There's quite a bit of SO2 across the globe right now at this moment, but you can see that Hawaii is got its own little system in here as well. So when we turn to our Mounts project, our satellite captures of SO2 over Hawaii Island, you can see here most recent image, and what you're seeing is this more dispersed SO2 plume across the upper atmosphere of over the islands here. So if I pull us back here to a week ago following episode 30 and kind of move it forward, you see there's a little bit more of that low level concentrated stuff here on the Kona side. And this is not just the pure sulfur, but the sulfate particulates as well that are produced when a VOG reacts with the sunlight and moisture in the atmosphere. And moving forward, since then, you can see more of this dispersal. Here's what we see with this low level. Sometimes the satellite captures this low level gas emissions, like you see right here surrounding Kīlauea, this grayish pixels right in there. And moving forward, drifting to the north sometimes with those southern winds. This was a Sunday when we caught that on the camera just now as well. Moving back southwest, sometimes these satellite captures, you can see this one, for example, it's only scanning anything south of that line. So it's really not capturing what's happening up here, but you do get a partial image of where that gas plume is going. It seems like it's drifting in that direction at low levels right there. So up, north, south, more localized, there, and here today, further up. So let's push a play button. You can see this animate a couple times here. And this is our inter-episode pattern that we see here. So we'll leave it at that today for our volcanic hazard summary. Still the gases and the tephra fallout, dependent on the wind direction as well. So that's what we have to share. And now move on to our monitoring signals today. So to start, I'll recap the USGS update that followed episode 30. This is from last week on Friday. It's supposed to be here. There it is. So here we are from last Friday, August 8th. They noted at that point the summary of episode 30. Fountains reached up to 165 feet, 50 meters. It was a revised value down from 80 meters, 200 feet. And lava covered 80% of the crater floor during this episode. However, they do note that 80% of the crater floor now includes the old downdrop block. So that may be a little bit of a shifting target with that little caveat there. In any case, a whole bunch of the crater floor, maybe all of the recent stuff was largely covered. Plus, there's still a little bit of downdrop block that maybe 20% of it, of that whole area that is not as covered. So at that point, they say models showed late this week or next week. And they noted that there was incandescence glow from the north vent on the night of August 6th that diminished by August 7th. And since then, and this is still true, no glow from the north vent. The other vents, in fact, the south vent has shown glow, and we'll see that in this more recent update here. But let's see here. Early on, they've now revised their analysis to note that even though the models show a window of this weekend or next week, changes in inflation rates do affect the models, and periods of no inflation to negative inflation or deflation, as seen prior to episode 30, cannot be modeled and will delay the onset of the next episode. So this is basically the forecast of the possible start of the window, which can shift back with time if the inflation rate also seems to stagnate. So they do note here, another factor was the injection of a shallow dike, resulting in a new southern fissure vent at the onset of episode 30. This suggests that eruptive pressure continues to increase. And this is because the vent elevation is getting higher. So it has to build more pressure to escape out of that greater overlying pressure. And as a result, that greater pressure can then inject magma into weak areas of the surrounding summit. It's possible this could result in permanent change in event locations and eruptive behavior. So we're waiting to see that. Currently, there are no indications that any activity would occur outside of the summit region. And I will add that the fissure that we saw opening up last week, after its 3 hours of glory, shut off even before the rest of the vents during the episode. And we have not seen anything coming from there since. There's been no glow, no gas emissions reported. So it seems like that was a transient relief valve, we'll call it. And we have to assume that the most likely areas are still the main vents, the north vent and south vent, that have been the most active over the last 8 months. We'll see, though, that there's reason to believe that could shift once again, and this underscores the need for this language here in the USGS text update. So this was the one that put out Friday. I'll skip everything since then until today's update, where we have the most current information. So in their summary, they're noting models show fountains likely to start between August 16th, that would be on Saturday, and August 20th. They note here is the documentation of weak glow visible at the south vent. The previous day, they know it was more intermittent and weak as well. We're still seeing low frequency tremor bursts that are characteristic of the gas pistoning process, those gas pistoning cycles that we've seen bring lava to the surface, spill it out, and then drop the lava back down and kind of up and down like a piston, relieving that gas poor magma from the column. And then when you get rid of enough of that stuff, then you can essentially effervesce and bubble up. The stuff below can rise more easily because it's not being held down by the denser stuff on top. So that process is happening as detected by the seismic signals, but it's happening deep inside the vent. Maybe when the lava is coming up closer to the surface, maybe that's when we see the weak glow from the south vent. But there may be some shallow blockage on the north vent. So maybe the lava was slipping back into it after that first day. That's something that blocked it off shallowly. We still think that's happening deep underneath there. It's just not reaching the surface where you could see it either glowing or spilling out, right? But it is happening down in there. So just to restate here, overall, the lack of glow may be due to lava residing deep within a vent, or the vent may have developed a shallow blockage. Right? They note that of the amount of tilt that we dropped in episode 30, we've recovered, call it 70-ish% of it, maybe not quite to 3/4 of the way. And so were we to maintain this rate, that's what gets us to Saturday and beyond for the onset of the episode. But if we do flatten out, then it would be even further, more likely into next week. Once again, I'm noting the rift zone showing no signs of extension, no earthquakes or evidence of magma injecting. And so here we have a little bit more detail on this forecast, right? So they note one possible onset between August 16th and 20th, with the most likely period the 17th and 19th. However, if increasing vent elevation is factored into the model, then the likely window changes to August 17th to the 21st. So it shifts back another day, right? This is still without changes in inflation, which would affect the models. And once again, periods of no inflation or deflation, as seen prior to episode 30, cannot be forecast and will also delay the onset of the next episode. Yeah. Same statement about the weak areas around the summit here. And so that's where we are. And so to look into this a little bit further, how I'll start off is let's take ourselves to the Mounts project here. Mounts is a project that's capturing these satellite passes of Kīlauea volcano and using INSAR, which is a satellite aperture radar based measurement of the ground surface. So we're measuring the ground surface, coming back and measuring it again, whether it's 6 days later or 12 days later, or sometimes even longer than that. And we can compare those snapshots one to the other. Right? So our most recent snapshot comes from, let me zoom this in, comes from today, the 14th of August, and it spans the previous 6 days during which we've had all of our recharge, right? So this has all been during our pause, reflecting what's going on here. And so when you look at this, without getting too caught up in the details of how it works, the center of this rainbow, we'll call it, is this area over here, which is actually centered on the eastern part of the crater floor. Now there can be a little bit of shift depending on the look direction of the satellite and all of that, but you can see that's within the crater and it seems to be shifted more on the eastern side. And if we look at the pattern of increasing color is green to orange to red to blue to light blue, and so that's this direction towards the radar. So the ground is swelling in this area, and it's swelling the most where this bullseye is located. Now that also seems to be the same pattern from here. So it's the whole thing is swelling. It seems like the larger area, the whole summit area, and it's especially shifted south of the caldera, which is typical. This is where we have long seen signals from the deep caldera, the deep magma reservoir that's in this Kīlauea area, more in here, that feeds more shallowly to underneath Halemama'u in here. So we do expect to see this broader and shallower pattern. There's a little bit of a bend, a little rotation happening in this area right through here, which is where we saw our fissure break open last week. So there's still some complications happening in there. So that's the interesting part here. And we also see a little bit of this, of the, what looks like speckled pattern or texture on our image here is a lot of chaotic changes on the ground surface, which is often either lava flows moving over the surface, making very random changes from what it was before, rather than the whole ground surface rising coherently all together as a unit, but just lifting or falling, right? We're seeing there's lots of small little changes that makes this this kind of speckled appearance that you see right in there, right? So that can be lava flows themselves on the crater floor, or it can be some of the tephra that is moving on a surface here, right? So since we did not have high fountains recently, it seems more likely that what we're seeing here is the result of wind continuing to move this material in between our fountaining episodes and causing this redistribution of the ground surface a little bit chaotically in there. So that's the most recent snapshot we have. Let me zoom this out so we can more easily compare there. Is that good? Okay. So that's our most recent one. Let's go back one capture here. So this most recent capture was captured on the 8th. So last week, and it spans the previous 12 days. So this is capturing the actual release of episode 30. And so we see a little bit different pattern than we saw previously as well, right? So what you see here is a pattern of going green to blue to red. So green to blue to red is away from the radar in this case. So you're seeing a kind of sagging in the ground between a snapshot that occurred during a buildup and the one that occurred after the episode. So it turned out that it was lower than when it began, even though we had that ramp up in between that is not captured when you snapshot a whole week. You can't get the detail day to day, depending exactly when your snap happens to be. So we're catching that larger deflation and that lava flows on a crater floor themselves. And perhaps one of the more interesting things to me is when you do see more coherent signals like this orange purple, that looks like something more coherent. And this is that same area that we saw from our B1 camera where we see that whole lava flow settling down from losing gas after the episode bursts out and since flows to the eastern part of the crater floor. And so that was episode 29, but same pattern that we've seen for several iterations now. Okay, so that's the one previously. And let me go back one more, and I'm gonna go back now a full month before this, right? So we're looking at from first week of August back, essentially back a few days into July, and I'm gonna pull us back to here, pull us back to that last week of June and the first week of July as well. Right, so in here, I'm gonna flip this back and forth. Here we are. You can see that we similarly had, in that case, we had higher fountains. So here's our tephra fallout, our lava flows with an inner surface. But similarly, we're seeing deflation towards the center as well as we captured that previous episode's deflationary pulse. Right, so to compare it, there's kind of a lot to point out there, but let me flip it back and forth. There is beginning of August. That's the beginning of July. Right? August and beginning of July. So what we're seeing, it seems like it's a little bit more of a shift pattern towards the center here, and especially if I put July or August here to our most recent snapshot. So beginning of August, and here we are in mid-August. And you see, once again, it appears to be this shift coming over to the east. So this also seems to lend some credence and backing to this idea of the summit pressurizing, not as localized, but building more pressure that's broader, that allows injection into these areas and possibly new dikes and possibly elevating earthquakes around the area as well. So if I pull it back to this snapshot from last week, one last thing to show here is that in the middle of all this, we do have this signal right in there that's a little bit muddled, but that is the area of the most recent dike right through there. So it seems like we do capture a little bit of that, but it seems like that overall was a fairly shallow feature. It doesn't seem like that came from a whole different source. It came from the same vent area, which is what we expect, seeing the visual sequence of lava first occupying the vents and then amplifying and then opening a fissure at the same time there. So that is the satellite insight we can get. And it's not super in-depth because I'm not an expert on this. But what we can at least see is the locations and the patterns of inflation, and this centered on the eastern part of the crater is not something we've seen as clearly in the recent captures. So what else can we see? Here is our other monitoring data. Growing ground tilt at the summit, whereas the rift zone at Pu'o'o remains in a decreasing pattern. Earthquake counts have been average. Here's our earthquakes per day. Our average long term is about 30. And so our range here looks to be about 20 to 40 or so, right? You have to ignore the shoulders because like that data point are not capturing the full 24 hours of each day. They're capturing some smaller amount, and therefore the values are always lower on these two half bars on the ends. So really there's our true range, 20 to 40, not a lot of variation across our background. We sometimes look at this cumulative moment, this red line as well. And if you look at that, it looks like we have a giant jump right here. But once again, as with every other indicator, we have to look at the scale here. And in total, the cumulative moment is not jumping very much right here. And it's easier to see that if you don't want to go through and do all the math to zoom out to like the 1 month counts or the 1 year counts, and we can see that a little bit more easily. So I'll point that out here as we come across it as well. So depth versus time on this scale for the last week, it seems like it's pretty constant in the upper depths, with maybe a little bit of increase in some areas here. That may correspond to the south flank and summit activity, whereas the Deep Pahala is still happening with its regular, it's not like a predictable cycle, but it comes in pulses. And so you have a little bit slower, a little bit faster. That's all within a range of normal that we expect. Okay. So for the last week, we can see the earthquake map here. A few events around the summit. Try to get this in there. A few events around the summit. But most of those events are happening here on the south flank area, and mostly happening in this area south of the summit, right through there. You imagine as the summit's building pressure and expanding, it's putting pressure on the south flank over here first. And then as this moves and fits and starts, that's what will eventually allow a pathway to open back into the rift zone from the summit. That's a long-term pattern of the volcano. We expect it to continue long-term as well. We're not seeing that presently yet. We're in this kind of a honeymoon period here where the magma is all at the summit and not really threatening anyone in inhabited areas further down the lower East Rift. So this is great, but at some point we do expect it's going to change. The south flank is part of that. We are seeing it show signs of movement, but not as fast as before, evidently, since we still have all the activity contained to the summit. So that's the map for the last week. And then coming to the last month, zooming out, we can look at crater elevation. This has one stray data point that's in which these maps automatically scale. So it's really zoomed out. We can't see a whole lot of the pattern apart from each episode we jump up a few meters, call it 10 feet or so, up to 20 feet sometimes a little more, from the new flows that come and pave the area. Right? And that's how come the summit area is able to have more pressure that holds in the magma that has to break through all that added weight and all these layers on top. Right? So this is just the last month. If we were to go back to the last 8 months, you'd see a lot larger accumulation of elevation. Although we do have these data gaps, right, for some parts of them, including when lava hit the laser rangefinder a couple months ago. So looking at the tilt plot, you can see that these jumps in elevation correspond to the drops in tilt. That's when lava is coming out and the pressure is dropping underground before rebuilding and recharging. More clearly, the rift zone going downwards here. And so depending on where you consider your threshold to be, maybe it could be there, maybe it's in there, maybe it's there. We're possibly nowhere close to that. And depending, if you look, here's a sand hill station that's a little bit further south, closer to that deeper source. And on that one, you can see this barrier is about where we are right today, but we had to exceed it and actually cause an extra fissure last week. So we're close, but the dynamics are shifting. The locations may be shifting, so it's hard to compare exactly from one week to the next. It's kind of a moving target. So earthquake counts for the last month. There is our background number of 30, our range of 20 to 40. Looking at this, you maybe can see a little bit more of this pulsing nature. And there is our larger step and moment that we had this past week. And we look down here at this graph, and what we see is an increase in events really in the shallow areas, but no single large event, right? So it seems like maybe some little burst of seismicity there on the summit and south flank. You can see that looks like a pulse right there. This right here looks like a pulse. It corresponds to this increase in seismicity here. We have a gap right in there. There's our lull and earthquake counts. There's another pulse right in here, corresponds to that one. A little bit more of a lull. So you can see maybe the south flank, even though it's somewhat stuck there, it's starting to lurch a little bit. Nothing big yet, but that is another indication of the pressure pushing it. And we've talked in the past about the south flank, and the south flank is the southern boundary of the rift zone. And it's always this game of who's driving the car. Is it gravity pulling the south flank as a primary most important force that opens the pathway and allows magma to then more passively move into the rift zone? Or is it the pressure from the top actually pushing on the south flank that causes it to shift and then inject magma more forcefully into the rift zone because it just has too much pressure and needs to spread out to larger areas? So who's driving the car? Is it the south flank? Is it the summit? There's evidence for both in the past, right? So right now it seems like the summit is the one really driving and pushing the south flank and causing new fissures to open up as well. So that's the last month of time. For the last 3 months, you see the pattern more zoomed out, and we're back to Uekahuna at the northwest part of the summit. So there, by that measure, we can see we're not quite to that threshold we've seen in most of the recent episodes, and still have a little ways further to go. And since the very beginning, back to December 2024, those first episodes there, and you see that while the top of our threshold here has decreased more quickly at the start, in the first few months of eruption, that since then we've been at a fairly stable level, right? There are exceptions where we have abnormally low fountains and changes in the patterns. Here's one that got a little bit higher, our most recent episode with its unique fissure. And so there is a whole range of what could happen and when it could happen, depending on the details of the dynamics of where it's building and all that kind of stuff there. So that's our tilt since onset. And now if we look at the last year of earthquake counts, earthquakes per week, back in December was when we had our build up to the current eruption. Since then, it's been pretty low. We're like we said in our summary, we'll watch to see if this possibly increases with building pressure or not. But now we can see that within the last week, that little jump in earthquake magnitudes is really quite minor compared to what we've seen in the past, especially a year ago. This was the build up to the Nepal eruption on the East Rift Zone as well. So very different looking picture from a year ago. So GPS, we are seeing this expansion, maybe 9 or 10 centimeters at a time there. That seems to be happening as well here. That's not really any different. With this overall pattern, it seems like the summit is lengthening long term. So the accordion is moving out and back and out and back, and the net is that it's getting further apart, a little bit further apart each time. Right? And so that's also suggesting that the summit is spreading, even though most of the summit stations are not rising in elevation. It's kind of spreading and sagging in as the pressure is kind of popped out the middle of that thing. Right? So that does also affect the south flank through its movement, even if it isn't rising as much there. So that's the summit area. And at Pu'u'o, we see this contraction with no real change ever since about a year ago. And we started seeing that inflationary pattern leading to the eruption of Nepal, some recovery. And then once eruption began in December, we saw the diversion of any magma from the rift zone back to the summit. And that's the honeymoon that we're currently still in here for the last 8 months. So those are our monitoring signals on Kīlauea. I thought that we could update just a timeline a little bit more. So as we mentioned, revised downward fountain heights, and we have a volume here as well. While we showed you guys these summaries at the top, we can now compare them to Pu'u'o as well. So what we can say is that our 2 in a row low fountain, episodes 29 and 30, is not something that was really visible in a Pu'u'o phase. Once it got going, you can see that did occur early on. You can see maybe episode 4 and 5, and 11 and 12 here seem to be a couple back-to-back lower fountain heights. But at Pu'u'o, when they started seeing these decreases in heights, that to them meant it was the beginning of the decline. It's not the same situation here in Kīlauea summit, right? Because the pressure can build without having to disperse in the rift zone. It's a smaller area, slightly different dynamics there. So while we're seeing a little bit different pattern in Pu'u'o, I'm not convinced that this means that we're coming to an end here. In fact, it might just mean a change in the dynamics, but clearly things are shifting in a way that the USGS is also putting out these caveats that the event locations might change, the nature of eruption might change, the character might change a little bit as well. So we pointed this out. Eruption volume at 8 million cubic meters is the third highest. Right? So it looks like, I'm not sure which 2 of those first 3 episodes had higher volumes. And so here we are, really high volume, and we're in this building volume trend for the last 10, 12 episodes or so, right? Volume's been going up fairly steadily after having initially decreased from that high. And now comparing to Pu'u'o was a slightly different cadence. That's to say that their eruptions are about once a month as opposed to once a week or week and a half that we're into now. They also had these high values at the start, occasional other ones as well, with this decrease. And they did see some increases as well. And that was more in the middle of their sequence, right? And once that increasing volume trend turned around, dropped down, and then came up, and then you can see here that pattern right there. Once it dropped down, and did this more of these wiggles, that was, in the case of Pu'u'o, the sign of decline there. So from that point of view, it doesn't look like we're ending yet, if that is a comparison that can be made, right? So a lot of lava is coming out. It's coming out efficiently, and it's doing it without the high fountains. So once again, discharge rates, cubic meters per second, right? This is based on, call it 12 hours of fountains for episode 30, 8 million cubic meters. That gets you to some number that's a little bit underneath 200 cubic meters per second. These are preliminary. This includes the gas in there, right? It's not the same as what they call direct rock equivalent, where you might subtract 30%-ish, depending on the volume of gas you have in your lava and how much is degassing and all of that, right? So you can't quite compare the absolute numbers, 200 here to 200 there. But if you were to subtract roughly 30%, then you can maybe get somewhat in a ballpark, more or less there, right? So we're looking more at the trends rather than the absolute values. And on that, you can see that, yeah, over time, this is just time, days from the onset. So 1 is at the left and 30 is at the right. And so they're all in a sequence here. Over time, there's a clear increase in our discharge rates over time, right? So lava is coming out easier each and every time. There's a little bouncing around. If I were to connect the dots here, you can see there's more of this wiggles happening, right? So when I draw that cloud, it's taking the average of the whole pattern there. And at Pu'o'o, we saw that as well, up to a certain point when afterwards we did see the decline as well. So we're not seeing that yet. It seems like we're still in a good place as far as lava coming out from the summit. The complication really is this building summit pressure because of the elevation of the vent getting higher and higher and higher, right? So that's what can change our fountain height versus discharge rate. And so episode 1 and episode 30 are the two most similar in this whole other era, right? Otherwise, what you can see is that as fountain heights go up, so does the discharge rate overall. That's the main pattern you see here, right? Which has been pretty different. At Pu'o'o, they saw more of a shotgun blast. There's not exactly, you can draw a line through in any direction you wanted to, and it's going to be equally unsupported, right? There's no clear trend right there. So we did see a trend at Kīlauea Summit overall, but we are breaking that trend, right? We're getting more to the shotgun appearance by adding these low fountain height episodes that have high discharge rates, right? So episode 1 was before we had any vent system whatsoever at the summit. We had to break through the cold, hard rock and through the ponded lava lake that had been there before from the previous eruption since 2020. But we were breaking through the side of the crater. Those first fissures came up on a wall through harder, older rock. And that's the pressure required to create a fissure, right? And so what happened in episode 30, once again, is that we did that. Even though we had lava coming out of the main north vent and south vent, that wasn't enough. And we had to break open another segment of the fissure to release that extra pressure that had built up to the south there. So it really is like a reset. You can see here, almost like we started over. But also not, because we still have the north vent systems that do have those conduits, that do have the tremor with the pistoning happening within them. So it's kind of a new chapter where we can expect those vents to reactivate, but also we could have these new fissures near where we had them last week, or possibly shifting to the east where we're seeing this INSAR buildup occurring as well. So we'll wrap up our monitoring there and just add a little bit more on the earthquakes. So let me pull up the earthquakes map here. This is the last week of earthquakes on Hawaii Island, colored by depth. Here's our scale. Reds are the shallowest, blues are the deepest. So we have in deep zone in blue here, the Deepahala earthquakes, seemingly clustered with one cluster onshore towards Mauna Loa, one offshore towards the volcano formerly known as Lo'ihi, or presently known as Kamaiahu Kanaloa. And then we have a little bit more of a string towards Kīlauea as well. So those are the patterns of the deep events there. And looking shallower, we have Kīlauea Summit showing a few more earthquakes. And this also is something that you would expect with building summit pressure coming up towards the next episode. So there's that. We noted already the south flank events from the magma pushing the summit area swelling to the south, right? So the summit's, it's not the magma reaching all the way down to here. It's a magma in this area trapped in here and pushing the rocks surrounding it, and those rocks pushing over here, and then those rocks causing these rocks to move. And then that's how the whole dominoes affect each other. And we've seen this for the last week or two as well. Earthquakes on this northwest flank of Kīlauea in this area between Mauna Loa and Kīlauea. So Mauna Loa also has a southeast flank that likes to move in this direction and can do so when Kīlauea is not putting up any fight, we'll call it. But when Kīlauea is extra swollen, she starts pushing back, and then you have this kind of pinch zone in here, we'll call it, right, where you can have this extra movement and extra earthquakes occurring. So that might be what's happening here. There are, these things do move independently also normally, but when you see an increase in rates, it's very small to note here. That might be something that's going on. So there and there, as well as these shallow ones right through here as well. So overall, it does seem like we're seeing increasing pressure to summit, more so than we've seen during other periods between these episodes. In the past, we've seen essentially dead quiet except for the tremor in a pipe. And now we're seeing the tremor in a pipe and some extra rumblings further out showing the pressure is building. And in this new era, we could have newer outbreaks, and all still within the summit region, at least now. But very dynamic, and its effects spreading outwards, right? So that's a very fascinating thing to see. It's the result directly of how much lava's come into the crater since the beginning of this eruption back in December 2024. So a lot of lava, and so finally coming to affect the dynamics as well. So this is the last thing I'll show you, the earthquakes for the last week sorted by size. The largest one was a 2.8 all the way out here near Kapoho. So that is also part of the south flank. That could be some settling or movement of this flank area, but once in a while is not what you worry about. That's normal. It's kind of like cracking your knuckles or something, right? It might happen once in a while. It's what you worry about is if it starts happening all the time, then something is going on there. And so we're not seeing that yet. It's just normal movement in the background. We know the ground moves there and it's still settling and adjusting there. So, all right, so that's our earthquakes. I will leave the rest of the visuals and other stuff to the guys. I appreciate you guys filling in here, and my apologies that I could not join you quite live and had to record this a few hours ago as you watch it now. So appreciate everyone's support. Stay tuned for our next episode, and if it does not come before our update next week, then we will update the stats at that point, or we will have a chance to review what else has happened, right? So a little bit uncertain. I myself personally think that it might delay a little bit longer, and we'll make it for an interesting update next week. All right, you guys, back to Dane and Lou, and aloha, everybody.
There we go. There it is. Now,
All
right.
Now we're back. All right. So from here, we did have Volcano Watch come out from USGS HVO. This one focuses on the impacts of water up at the summit, as well as on the rift zone. Kind of everywhere is influenced by the water. But the most significant ways in which it's been studied has been through the Keller well, which is seen here. We'll take another look at that too. A borehole drilled in 1973 to a depth of 4,140 feet. And typically the water sits at about 1,600 feet, but it dropped about 60 feet during the 2018 eruption. And since then, we had the return of the water lake inside of the caldera, and since removed, but there were samples taken of that. And one of the takeaways from this is that on average, plumes on Kīlauea, which those big bellows of whites, those are 90% water. So it's not, all poisonous gas. The white smoke, I remember it, 2018 clearly always was, a fissure or an ocean entry. Or black smoke wasn't good. That means it was destroying something. So interesting article. You can look that up on our website over at hveri.org. We have this posted. Also wanted to show a video that USGS put out on the Kīlauea. Messing with it. I say messing around, but I mean, it looks fun. You seen the
big well, huh? 1,700 feet. Yeah, I watched that earlier. Yeah. It's a deep well, huh?
Yeah.
We were just talking about wells here for drinking water and how deep people have to put them down.
Yeah, that's an expensive project to put a borehole that far down nowadays. But in 73 they did.
Mm-hmm.
And they're able to get the water samples, which they've done since, and be able to track little subtle changes and everything. So did want to show that.
Over the decades, it's still usable with all the swarms of earthquakes everywhere, the ground continually moving. It's still accessible.
Right. Pretty cool.
Mm-hmm.
And they did mention in that article that if you want more information, it's available here in the professional paper 1867. This is a rather newer publication, but Shaw Hurwitz et al. Involved in that with some major editors on board as well. So if you want to check that out, it is on USGS's website. You can see the link here, and it looks a little bit like this. A lot of pages here, a lot of information to go through, very detailed. Only 30-something pages, but still
not bad.
Worth checking out if you're interested in this. And with that, I think we're transitioning to a different body of water influenced by Kīlauea, and that was a Pohiki, which was inundated with sand. And since then, we have been watching the process of getting rid of the sand and the dredge ongoing down there. You can see here the last week worth of footage. And I wanted to show this just as we talk about Pohiki, but we had some rather large surf come through this weekend. And we can see here coming up is
kind of our first test, huh, Dane? Right?
All of the water coming up over this berm that exists out there and removing a lot of the sand, leaving more of the rock exposed. So that's a change from what it had been. And just wanted to highlight that. Not a lot of change has happened in terms of construction. This is a time lapse of the entire construction process so far. We're not going to go through all of it, but just want to show how fast construction went through, and then the long period of waiting for the crane to arrive, which should be arriving soon. And then they go through the process of assembling the crane and then getting into position. And really, at this point, there's little more work that gets done, right, throughout the rest of this time lapse. But there was a little work today that occurred that we were able to capture. And we see that they went out there and basically fixed that levee, built it back up, put in some more sand just to be able to use it when the crane gets here. Because that was the plan, is to use that as a access to the other side and then work your way back out of it, and while removing the sand that provides that barrier. So kind of interesting that beach is still alive. Yeah, Lou?
Yeah, it's still there, hanging in there. I wasn't sure. I was watching those waves that morning on Sunday morning when I was looking at everything. We were kind of concerned on how much, that was minimal impact, and anything bigger. It wasn't just the wall getting broke down that I was watching. I was watching the surges of water kind of push across the pond and show how an extreme weather pattern that comes through could really push a massive amount of water. And go back to that shot one more time. There you go, Dane. I think if you can see the lifeguard tower that's out there, the bay originally extended all the way out there, so the water had an area to kind of push out.
Right.
Yeah, it's an interesting project.
Definitely. You know, a lot of variables at play, and then those south swells really change up the game.
And I saw in the chat somebody had mentioned that caused by the hurricane. Well, the Hurricane Henriette, it was way north of the islands at this point. So nothing was really out there. I don't know.
I think it was just a south swell.
It's kind of what we were putting together, right?
Right. Which happened in the winter, right? That's the time that we think of south swells occurring down there. So anyways, that is our Pohiki update. And with that, I think we can dive into our community corner, huh? Oh, no, one more. And that is the construction beginning on Pohiki Road, starting at the top by the Y with Highway 132, and being able to push down there, regain access down to Pohiki, so don't have to go through all of OPE-CAL. It's such a faster route to have reestablished. It's not going to be an easy project, but it is underway, and been seeing it progress since then. And thank you, Jason Twillman, for posting this at the very beginning stages on Hawaii Tracker, just keeping people informed. And now we can go into Community Corner.
All right. Dano could go ice his shoulders. Here we go. All right. Carrie, you fresh? You ready? You guys got a workout with Phil tonight, I noticed. Good job. All right, let's move through our community corner tonight. There's still some closures going on up at the park, even though they are working as fast as they possibly can. We're going to go through those. It's a wonderful picture from the last episode from Janice Way, and it's a reminder that you can take those pictures inside the safe zone. Stay on trails and beware of steam vents, earth cracks, and cliffs while you're up there. The roundabout and realignment work, well, the project is completed. The roundabout is part of a larger plan to realign the Crater Rim Drive that includes an additional lane for park staff and partners at the entrance and an exit pull-out before the highway. The entrance realignment project may make driving in the park much easier and safer and will be finished by the end of September. And I emphasize the word may make driving safer up there. Just go slow. There is our Kīlauea military camp where you can get all your information of what's going on in the park. A map there in case you don't know how to get to it through the entrance and all the way up. You can't miss it. There are signs everywhere. I wanted to bring this up because I've had a couple questions come to me in the last week about water. They still do not have their faucet filling areas open yet. Visitors to Hawaii Volcanoes National Park need to bring their own drinking water for their park adventures. The water station at Kīlauea Visitor Center is unavailable during the renovation closure. A bottle filling station will be reinstalled at Waikahuna once it reopens in the months ahead. Water is available for purchase at Volcano House, but please know that the store might not be open, and I don't know if they sling bottles from behind the counter. Do you, Dane? Maybe they got a garden hose out front.
Yeah, I don't know.
Highway 11 hole drilling and power pole placement is going on. Now you're going to see the guys on the side of the road. Dane and I, when we went to, what were we going to, Ocean View or Kau? We were noticing all the construction, all the tree trimming on the sides of the road, and that's all their power poles. The sections of the line were built in the early 1950s. The project went out to the public for comment. There's some more information online if you're interested. Just be aware that they do stop traffic while you're going up the park, and those guys are looking for everybody to slow your roll. Here are the closures that are going on in the park. Temporary closure of Kīlauea Iki Trail Western Switchbacks. The Western Switchbacks of Kīlauea Iki Trail are temporarily closed for repairs Monday through Thursday, 6 a.m. to 4 p.m., but open to hikers at all other times. The rest of the trail remains open. How we doing, Carrie? Good. Mauna Loa Road is still closed past the Kipuka Pualu and Helena Pauli Road. Campfires are not going to happen right now. It is dry out there. We had some rain today, but you can use your propane and gas cooking stove. Backcountry hikers with a permit will be provided access to the end of Helena Poly and Mauna Loa roads. Go to the Kīlauea Welcome Center for that information. There is the Helena Poly Road, the overlook there. That is a hefty hike if you want to do it. If you want to make it out there, pack your water. And Life on the Edge is the one reliable program I know that's running up there. It's every day. You can go in there and inquire about others. They don't have them on their website. So I recommend, if you're looking for more, go and talk to them. But they do have the Stewardship at the Summit volunteer to help remove invasive non-native plant species that prevent native plants from growing in Hawaii Volcanoes National Park. I know a lot of our viewers are volunteers. This is one of those that you can go to on Saturday, August 16th at 8:45. Make sure you wear sturdy hiking shoes, long pants, bring a hat, rain gear, day pack, snacks, and water. Gloves and tools are provided. And we also have the 2025 Community Weed Pool, Malama Mauna Kea Volunteer Invasive Species Weed Pool going on up at the Visitor Center. That's this Saturday, next Saturday, August 23rd at 9 a.m. This one here is up high altitude, so if you have issues, know that you're going to be several thousand feet up. There's your list of everything you need to know. I'm going to drop the link so that you can sign up for this in the chat as soon as I'm done here, so that you can attend that if you would like to. And the Pacific Tsunami Museum has something going on. They are happy to share that in their goal to save the museum, they will be serving the community with rapid response to the recent tsunami. We're going to cover some of that in a little bit. The last time Hawaii was asked to evacuate for tsunami was 14 years ago due to the 2011 Tohoku tsunami from Japan. This is a critical time for the museum to shine, support, build, and collaborate. 2011, wow, 14 years ago. Time for everybody to get a refresher. And here is a way to stay updated to everything we're doing here at HVERI. Sign up for our subscriber list for our newsletter, as well as our volcano eruption notification. We'll let you know, even if it's at 1 o'clock in the morning. One of us will send out an email of what's going on if the episode is started up. So let's check that out over there. Dane just dropped the link there. And there we go, Dane.
Yeah, so I'd like to thank everybody for tuning in today. But first, I'd like to thank the 5i Grant program for helping fund this program, as well as our youth development and digital resilience programs. Appreciate the county's support on those. But really like to thank all the viewers, the donators, the supporters that we have, the views, the you sticking with us. All that stuff really helps and keeps us going. So thank you all. And yeah, we see some of our donators there. We did have some donations come through, Lou.
We had a $50 donation from Kailoki's over in Ocean View, a spot that we have stopped at. On the last time we went there was one of the Mauna Loa meetings.
Right. All right.
Yep.
So thanks, everybody. And with that, I think it's time for some fun.
All right. Let's get our switch out our logo here.
You do need to donate. Throw out the donation link if you do want to make a donation. We take those over at hveri.org/donate. All right. So
I got it.
Let's go ahead and switch modes. So one thing we saw in the recent Kamchatka magnitude 8.8 was social media really being overwhelmed with the amount of fake AI generated content showing fake tsunamis. This was quite prominent when Lou and I were searching through social media the day of the earthquake and then the hours following while we waited for the tsunami to reach Hawaii and then eventually California and the rest of the Pacific seaboard. So we wanted to go through and highlight some of these. And one of the interesting things we realized in going and looking for these things that we know we saw during the event is some platforms out there removed said AI generated content after the fact. Now that's interesting because during the time that it matters, it's there,
Right.
you go back to try and prove it, and it's gone. So we went and captured as much of the stuff that we were able to. We're not going to show everything that's out there, but we had some good ones that we, maybe laugh at, or, maybe there's something to learn in there, but wanted to just show how prolific all of this was, and, leave us alone for a little while. Phil being gone, we started talking about this type of stuff again.
Yeah, one thing I'll throw out real quick before you hit play on that is not just the visual imagery that's happening, but we also see all the comments in there. And sometimes there's a good run of people commenting that this is fake, and other times people are pulled in by it. And it's unfortunate. And part of what we're trying to do is teach everybody to be aware and how to recognize some of these things. And roll it, Dane.
All right, let's get our first one. And again, these things are wild. Some of them better than others. Usually the more subtle ones are the more effective and take us longer to look at. But these are in no real particular order. Let's just get through it. Absolutely insane things that we're seeing. Right, and that's one of the main things that I see about, again, this is supposed to be Hawaii. That's not English.
No.
There's so many things here that are indicators. So this is fake, but you got to like the shaky cam element to it.
I mean, they tried with Aloha Stadium there, but then we end up in somewhere in India.
Yeah, I do not know. It's just, again, it jumps around. None of it really is coherent, but we can see people's desire to make these types of things and make dramatic, crazy events and share it on social media. All right, that's enough of that one. We got more, though.
Oh, yes. Oh, yes, we do.
And this one was one of my favorite ones just because the house turns into a speedboat, and you'll see what I'm talking about. You can see here, though, the house is just going into the ocean at Mach 10.
Yep.
And then
somebody's still there filming.
This one's also funny. I mean, where is this peak over this beach?
How is that snow?
Yes.
Yeah.
I mean, it makes for a good vantage point, but how?
Yeah.
And then this is also just a repurposed footage from something else entirely. Like I've seen that footage before.
Yeah, that is possibly could have happened in Japan.
And it's weird because, like, without that AI slop, the message here ain't the worst. After a massive 0.7 earthquake off of Russia's Kamchatka Peninsula, tsunami waves could now be heading towards Hawaii and broader Pacific coast. Like, that's a good message.
Yeah.
Except then it's paired with
garbage.
That monstrosity of an AI slop video. Oh, I went too far. Let's go back one. And this one was one of the most prolific ones I saw.
Yeah, definitely.
Right. And there's just random audio on these things, like conversations in the background. But the wave, generates out of nowhere. And again, the AI doesn't know the difference between like a tsunami and a big wave. So a lot of the stuff we're going to see are just big waves crashing into city and calling it a tsunami. Right. When it's a different phenomena at play. So I want to just continue to go through these. I think this was one of your favorites, Lou.
Yep, absolutely.
This one, at least, they kept the VO, the generator tag on the bottom right, but a lot of people just immediately get rid of that thing.
A little cropping and nobody sees it ever again.
Yep. And even if you don't, I mean, could you not just have AI remove
You could.
the thing? And then, that one's more, again, big wave.
Big wave. But the problem here is that massive of a wave, nobody really fell down.
Oh, yeah.
They're all still standing there.
Yeah, it's crazy what's all out there, but this was all put out during that event, right? So
again, this AI stuff is advancing very rapidly. So maybe it doesn't fool you today. Maybe none of this is, gets you.
Mm-hmm.
But it gets more and more subtle. And some of them, do. I wouldn't say this is one of them that's subtle.
No.
Again, big wave equals tsunami.
Did I just see the other side of the island on that image? Rewind that just back to the real quick. Right there. Start there.
You did.
Yeah, I did. I just now saw that. Look at that.
Yeah, the wall of water meets the water.
Yeah. So we have a peninsula somewhere here in the island chain.
It's a weird world when you start dealing with the AI. Lou. So this one is interesting.
My favorite.
This one, we saw this footage that you're looking at right here. This is real footage from the tsunami, the evacuation of Honolulu. You see the jammed up traffic going in both directions, not moving. So taking real footage.
And
nothing ordinary here. Go ahead.
A lot of these, if they start off like this, we would have blown right past them because we're moving fast looking for stuff, but it just happened to just keep it rolling, and then this happened. There it is.
10,000 people dead and a whale on top of a van.
Yeah.
Bus.
Yeah. Impressive.
So it goes from real and believable to what is happening very quickly. All right.
But the whale survived. Did you see the tail moving?
Yeah, right.
Mm-hmm.
So that was the AI slop. That was all out there. And that was something, it's easy to point your fingers at and just be like, oh, the AI is doing AI things and people's abusing it. But there were issues as well with people and their way of spreading information during the tsunami. And one of the big ones I want to harp on here is this map that was seen throughout, not just like social media, but by news stations, right? By meteorologists, by professional people in industry that you would think would know better. So this map appears and it shows tsunami warning. First wave arrive. And look how much of this area is highlighted. This has got to be up to like the 13-mile marker, which is got to be 1,500 feet.
Oh, yeah.
Or higher up.
Yeah.
The entire, all of Molokai is destroyed type of thing in this scenario. So we saw this, and it wasn't just here. We saw it at Fox 23. We saw it over at Kīlauea, right? Same map, different versions of the same map. We see it here. And then one more time, Weather Nation posted the same map. Can look at it there. Again, they're all just taking the same thing and, spicing it. The same GIS layer that they're modifying. The thing about it is this map also made it onto Hawaii News Now, that they were showing it during the tsunami. And again, tsunami warning alerts, and they're showing this map. It leads you to believe that it's connected with the tsunami. So in this instance, people are the ones that are going off. So I just asked ChatGPT 5, the new release of it, what is this map? What is the zone being shown on this map of Hawaii? The pink areas on this map represent tropical storm warning zones. Tropical storm. And you might think that, maybe AI's making that up. I've discussed this map with Civil Defense. They were aware of it at the time. They also pointed out that it was the tropical storm warning zones, that they were not relevant for the tsunami evacuation zones, which are much, much smaller. We'll take a look at those before we sign off. But I just wanted to show you, like, AI, again, it's a tool. How you use it can, dictate what its impact is. If you're trying to make fake disasters during an ongoing disaster, all you're doing is serving to confuse. But in this instance, you can have AI help you look at just an image, like these people are sharing this image. What is it? Just drop it in, and then it will tell you, like, oh, that's this. That's not an evacuation zone map, right? So it's interesting how the world in which we find ourselves in is developing.
Mm-hmm.
What do you think, Lou?
Yeah, I get on the national level how they just grab something and run with it, but to see local just grab it and run with it without really verifying, I was shocked to see that.
Right. So let's look at some real evacuation zones, right? And this is available over on the, just search Hawaii, tsunami evacuation zones Hawaii. You'll find this page. And each of the islands has each of the areas that are prone to tsunamis and have these evacuation zones. You can zoom in and see exactly what is the evacuation zone, right? So we can see here that it comes midway up and through Hilo, but we're not talking even all of Hilo.
Nope.
We're not even talking most of Hilo. We're talking about the coastal parts that have been prone to tsunamis ever since Hilo was built upon, right? And this is why this area right here by where Kamehameha is printed was Shinmachi.
Mm-hmm.
Am I saying that right?
You got it. Shinmachi.
And that area was destroyed twice, once in 46, one in 1960, never to be rebuilt again, turned it into parks, soccer fields, those types of things. So yes, the tsunami is a big risk. There's, these evacuation zones. If you live down there, like, let's go back one and open up a different one. This one from out by Richardson's. And everything out there up until the airport, is evacuating. We can see that escape road that was opened a couple years ago by the county, helping to provide access out of that area so you don't have to drive parallel to the coast. Now, we didn't think that would be as much of an issue with a long tsunami generated from maybe Russia, where we have 5-6 hours of lead time. But with how bad traffic was, yes, that it was opened, it was packed full of cars, they were barely moving, all those same scenarios that we encountered. But we just wanted to highlight the real versus the misconception that was being passed around of what is, the tsunami zones, and those tsunami zones representing the areas that could be impacted by even a very big tsunami.
Mm-hmm.
Right. And we've seen people freak out and say, like, oh, you got to go up to the saddle. It's like, no, you don't. No. In one of these tsunamis, it's not that far to be high enough to be safe. These are usually walking distance type things. Now, this is a bad area that I'm showing here, but
yeah, that's one of the most extreme areas, huh?
That's one of the most extreme areas. But if you go, say, Pi'ikau and Puna down by Pohiki, right? So it's inverted, right? So we're looking south is north on this one. You can see the label of north. But it doesn't even get, like the beginning of Seaview. It's just, it doesn't take that much elevation to get away from these things, right? So just be aware of your tsunami zones, so the areas that you're going to, know where the evacuation points are. There are signs. And if you do feel a locally generated tsunami, one that you have difficulty standing, you do not need to wait for a siren or an evacuation order. Just move up the hill already, because on those locally generated ones, the amount of time that you have until it could be on you is relatively short. We're talking minutes, tens of minutes, maybe less, depending. Yeah, Brett asked the question, if you had to go all the way to the saddle, would you even want to survive? And I've asked that same question before. But I've also told the people that ask me, they tell me that they're going up to the saddle. I tell them that's not high enough. You should probably go to the visitor center, or just.
If you're going that far up, you might as well keep going.
I mean, you want to take it to.
You already made that trip.
Yeah. Do you get some good pictures at least?
Yeah.
But yeah, I just wanted to highlight that and talk a little bit about some of the AI stuff that's out there, because it's only going to become worse. And
only worse.
My whole philosophy with this thing is the more you're introduced to it early, the more examples you're shown, when you encounter it in the wild, the more you'll be prepared for it. You won't know what it's going to be, but without seeing it, going into it blind, it's more likely that you're not able to catch the details or even the obvious parts that indicate fake AI generated slop, especially in times of natural disaster, when maybe the nerves are high, pressure's on, things along those lines. You can't get sloppy and start believing just because there's a video of, you got to look at stuff nowadays. All right, Phil or Lou. Phil's not with us.
Nope.
Too used to it.
Yep.
But appreciate everybody that made it with us this far.
Got a donation from James Olson for $10 on there. Thank you, James.
Yeah, thank you, James. And we can go ahead and get rid of that AI banner. We do try and label everything when we do show AI to make sure that if somebody screen caps it, there's multiple things indicating that it's fake. We try and be responsible while showing you fake AI generated disasters of real incidents that have happened, right?
Yeah.
So I think that gets us there. We're at the 1.5 hour mark. It's kind of weird episode this week, but we got it done, Lou.
We did. Yep.
Yep.
That was good. I'm glad that was a good way to I guess maybe some sort of a debrief or follow up to the entire tsunami that we had here. I think that was important and the way you laid it out and trying to educate everybody is important. And now everybody that's been watching us, when they see something come up, not only recognize, but help educate maybe their friends or family when they get those emails or those text messages saying, everything's gone wrong, they can point out. So kind of our chain here of education.
Yeah, definitely. And we'll only be, more ready for the next one because we know the AI junk is coming for whatever disaster happens. I used to have a saying that whenever a disaster happens, whether natural or man-made, there will be conspiracy theories on social media about it.
Yeah.
I call that like Dane's Law.
Yeah.
Never been wrong type of thing in the modern era.
Yeah.
The new one is the modification to it is that, and there will be AI generated slop of the disaster. That's the, little appendium that I'm going to add to it is that's going to just happen every time. Expect it. Right.
Yep.
And if it doesn't, you're lucky.
Yeah. Absolutely. One more thing, Dane. The reminder this weekend, August 16th at noon, the Tsunami Museum has their education program going on. So if you are here and you're interested in learning a little bit more, and you want to freshen up on some stuff, I put the link in there for the Tsunami Museum. You can check out their website as well as this flyer that they put out.
All right. Well, thank you, Lou, and thank you, Dano and Carrie, our ASL interpretation team, for sticking with us. We will be back next Thursday, 5 p.m. Hawaii Standard Time. Unless something, unexpected happens, the eruption at the summit is not going to count yet again. But if something, like a rift zone eruption were to happen, that counts. 5 p.m. Hawaii Standard Time next Thursday, and we will have Phil back, I believe, and don't know if you'll be with us, will you?
Nope.
You will be stepping away for a little while, so it'll be Phil and I, and we will get it done. All right. Well, thank you. Yeah, right. All right. Well, thank you, Lou. Thanks, everybody, for tuning in today. We did have one last donation. Wanted to shout out James with a $10. Mahalo.
Yep, got that. Yep.
All right. And until next week, I am Dane DuPont. He's Lou Attori, Carrie, and Dano. Aloha, everyone.